Good afternoon, everyone. Welcome to my first lecture. My first lecture will be on eigenvalues and eigenvectors of the given matrix. Before talking about this topic, firstly I will introduce myself. My name is Dr. P. Venkat Raman, Professor of Mathematics, working for Marri Laxman Reddy, Institute of Technology and Management. Actually, this topic related to the matrices and calculus, which is in the first semester of first year students of BTech. Now, in this, the main topics are introduction, eigenvalues and eigenvectors, properties of eigenvalues, Cayley-Hamilton theorem, finding inverse and power of a matrix by using Cayley-Hamilton theorem, diagonalization of a matrix, quadratic forms, reduction of quadratic form to canonical form by orthogonal transformation. So these are the main important topics in Unit 2. So now in this, we talk about the eigenvalues and eigenvectors. It is one of the important chapters in the matrices section. So actually these eigenvalues and eigenvectors are defined for the square matrices only. We cannot find the eigenvalues and eigenvectors to the non-square matrices. So before knowing or before discussing about the eigenvalues and eigenvectors and how to find them to the given square matrix, we need some important definitions. Firstly, we know them. So definitions, first definition is characteristic matrix. Suppose A is a square matrix. A is a square matrix of nth order. Then A minus lambda I. A minus lambda I, this is also a matrix. This matrix is called the characteristic matrix. For example, you see this example. A is equal to 1, 2, 3, 2. It is a 2 by 2 matrix. Now in this, it is a 2 by 2, and what are the diagonal elements? Diagonal elements are 1, 2. Now A minus lambda I. A minus lambda I means here what happened? A matrix minus A matrix minus lambda I matrix. Here I, what is the order of the I? Second order unit matrix. Because A is the second order square matrix, that's why you have to take unit matrix of order 2. A is 3 by 3 matrix, then I3, that is third order unit matrix we have to take. So now here 1, 2, 3, 2. Similarly minus lambda 1, 0, 0, 1. Now this is equal to what happened? Now subtraction 1, 2, 3, 2. This is the first matrix, and multiplication 1 into lambda. This is lambda, and 0 lambda, that is 0 lambda. This is 0. Lambda into 1 lambda. Now what happened? Now this matrix minus this matrix. So just 1 minus lambda, diagonal corresponding elements subtract. 1 minus lambda. 2 minus 0, 2 this is. And 3 minus 0, this is 3. 2 minus lambda, this is 2 minus lambda. Now what is this? It is again a matrix. This matrix is called the characteristic matrix of the given matrix A. Okay. So when you observe this A matrix and this matrix, we can say that we got this characteristic matrix by subtracting lambda from the diagonal elements. You see 1 minus lambda, this is 2, 2 minus lambda, and 2, 3, and same. These values, no change in these two values. So from these steps, I can conclude that we get the characteristic matrix from the given matrix A by subtracting lambda from the diagonal elements of A. Okay. So this matrix is defined as the characteristic matrix, and we denote this matrix by A minus lambda I2, A minus lambda I. Next, second definition is characteristic polynomial. Characteristic polynomial, what is a characteristic polynomial? For example, A is a given square matrix. Then A minus lambda I is defined as the characteristic matrix. Characteristic matrix. Now you take the determinant of this. Determinant of this is a polynomial denoted by pi of lambda. Denoted by pi of lambda. It is a polynomial only, polynomial in lambda we will get. So this polynomial is defined as the characteristic polynomial. And third definition is characteristic equation. What is a characteristic equation? Same, characteristic polynomial A minus lambda I determinant equals 0. Equate to 0, then it is an equation, and this total is called the characteristic equation of the given matrix A. A is the given matrix minus lambda I determinant. Determinant equals 0. This is a matrix. For example, A equal 1, 2, 3, 2 is a 2 by 2 matrix. Then what happened? Determinant A minus lambda I, characteristic matrix determinant we take. Now what is this? You write same as it is, 1, 2, 3, 2. Now what are the diagonal elements? 1, 2. So from diagonal elements subtract lambda and equate to 0. Okay. Now this is the characteristic matrix and its determinant, and now you take the determinant of 2 by 2. What is the determinant of 2 by 2? Formula A, B, C, D equal 0. Then AD minus BC equal 0. This is the formula for the 2 by 2 matrix. So here what happened? 1 minus lambda into 2 minus lambda minus 2, 3, 6 equal 0. Now you multiply this, we will get 2 minus 2 lambda, this is minus lambda, and this is minus 2 lambda, and minus minus plus lambda square minus 6 equal 0. Now what happened? Simplify. You just when we simplify this, we will get lambda square and minus lambda minus 2 lambda. This is minus 3 lambda. Here plus 2 minus 6 is there. So plus 2 minus 6 minus 4 equal 0. Now this equation is defined as the characteristic equation of the given matrix A. Now here the next definition is what are the eigenvalues and what are the eigenvectors. These eigenvalues also known as characteristic roots or latent roots. Similarly, eigenvectors also known as, or we call eigenvectors as latent vectors or characteristic vectors. All are same but different words. Now next, what is the characteristic roots? Suppose A is a matrix. A is a matrix, given square matrix. Then what happened? What is the characteristic equation of this? A minus lambda determinant equals 0. Now it is a equation of lambda, and the degree of this degree of this equation is nth degree. Suppose A is the nth order square matrix, then it is a nth degree characteristic equation. Suppose it is second order square matrix, then this characteristic equation is second degree characteristic equation. So therefore, it will have the roots of this equation. The roots of this characteristic equation are defined as the eigenvalues or characteristic roots or latent roots. Okay. Similarly, characteristic vectors. Suppose lambda is the eigenvalue of a square matrix A. Suppose lambda be a eigenvalue of a square matrix A. Then if there exists X, if there exists a vector, non-zero vector, such that A minus lambda I into X equals 0, if there exists X, such that A minus lambda I multiply X equals 0, then this matrix is called this vector is called the characteristic vector or eigenvector of the given matrix A corresponding to lambda, corresponding to eigenvalue lambda. Okay, here A is the given matrix, lambda is the eigenvalue, and I is the unit matrix, and X is the non-zero column vector. Non-zero column vector. So this is the definition of the characteristic vector. Now we know how to determine the characteristic roots and characteristic vectors of the given matrix. So that we will discuss by solving one problem. Okay, before that we talk about the properties of eigenvalues. Now see this example. The eigenvalues of the following matrices are. Now you see this matrix I equal, what is the I here? Third order unit matrix 1 0 0 0 1 0 0 0 1. It is a third order unit matrix. Now what are the diagonal elements here? These diagonal elements are defined as the eigenvalues of this matrix I. Now what are the eigenvalues here? Lambda equal 1 comma 1 comma 1. Okay. What is the order of this matrix? Third order. How many number of eigenvalues? 1, 2, 3. 3 eigenvalues it will have. Okay. Similarly, what is this? It is a matrix of scalar matrix. And here scalar is 2. You see, same number repeated. 2, 2, 2. Here also eigenvalues are 2, 2, 2. So in a scalar matrix, the eigenvalues are diagonal elements. Okay, 3 elements. Now similarly, see this B example. What is this? Diagonal matrix. Diagonal matrix with different numbers. You see here 1, 2, 3. So here eigenvalues are 1, 2, 3. That means if the matrix is diagonal matrix, then the eigenvalues are the diagonal elements. Similarly, you see this. It is a upper triangular matrix. These 3 are 0, therefore it is upper triangular matrix. If the matrix is upper triangular matrix, then the eigenvalues are defined as the same diagonal elements. That is 1, 8, 6. These are the eigenvalues to the upper triangular matrix. You see this, it is a lower triangular matrix. In lower triangular matrix also, the diagonal elements are defined as the diagonal elements. What are the diagonal elements here? Lambda equal 4, 2, 1. These are the diagonal elements. Similarly, some properties are there. You see, if A is an n by n matrix and lambda 1, lambda 2, so on, so lambda n or its n eigenvalues, then lambda 1 plus lambda 2 plus so on, so lambda n is equal trace of A. And lambda 1 product lambda 2, so on, so lambda n is equal determinant of A. Okay. So suppose A is a nth order square matrix and let lambda 1, lambda 2, so on, so lambda n be the eigenvalues. Then sum of the eigenvalues, that is lambda 1 plus lambda 2 plus lambda 3, so on, so lambda n is equal trace of the matrix. Trace of the matrix means sum of the diagonal elements. So that means sum of the eigenvalues of A equal sum of the diagonal elements of the A. That is one property. And similarly, product of the eigenvalues, that is lambda 1, lambda 2, so on, so lambda n equal determinant of A. So that is one property. Similarly, see the second property. If lambda is an eigenvalue of A corresponding to the eigenvector x, then lambda power n is an eigenvalue of A power n corresponding to the eigenvector x. Suppose 2 is the eigenvalue of A, let us say. Then what is the eigenvalue of A square? Just you take eigenvalue whole square. Eigenvalue whole square means 4. So 4 is the eigenvalue of A square. Similarly, what is the eigenvalue of A3? Just 2 power 3. 2 power 3 means 8. 8 is the eigenvalue of A power 3 and so on. So, without finding A square, A cube, A power 4, so on, so A power n, we can find the eigenvalues of A square, A cube with the help of the eigenvalues of A. Okay, first you find the eigenvalues of A, then after that we can write the eigenvalues of to any matrix A power n. So that is the property. Third property. Now third property, you see, A is a square matrix and its transpose A power t have the same eigenvalues. For example, you see, let A is equal to 1, 2, 0, 3. It is a upper triangular matrix. What are the eigenvalues here? Lambda equal 1, 3. Lambda equal 1, 3. Now what happened? Here A transpose. If it is A, then what is A transpose? A transpose, just interchange the element, rows and columns. We will get 1, 0 and second row 2, 3. This. So this 1, 0, 2, 3 is the transpose of 1, 2, 0, 3. Now what are the eigenvalues of this A transpose? Same, it is lower triangular matrix, therefore eigenvalues are 1, 3. Here also, what are the eigenvalues? 1, 3. Same, you see. From these two examples, we can conclude that A and A transpose both have same eigenvalues. Now come to the fourth property. If lambda is an eigenvalue of a non-singular matrix A corresponding to the eigenvector x, then lambda power minus 1 is an eigenvalue of A power minus 1. Suppose 2 is the eigenvalue of A. Then what is the eigenvalue of A inverse? Eigenvalue of A inverse also, this is just you take 1 by 2. 1 by 2. That is 2 power minus 1. 2 power minus 1 means 1 by 2. Similarly, what is the eigenvalue of this? For example, 3 also eigenvalue of A. Then what is the eigenvalue of A power minus 1? 1 by 3. Like that, you take the inverse of that number, you will get the eigenvalue of A power minus 1. So these are the some few properties. Next, come to the problem. In problems, what happened? For example, you see, find the eigenvalues and eigenvectors of the matrix. Here it is a 3 by 3 matrix, 3 by 3 square matrix. Elements 8, minus 2, 4, minus 3, minus 2, 3, minus 4, 1. These are the elements of the given matrix A, 3 rows and 3 columns. Now, how to find the eigenvalues of this matrix? So, first we find the solution part. First part is eigenvalues and second part is eigenvectors. First we find eigenvalues of A, this given matrix. Now what we write? First we write the characteristic equation. The characteristic equation of A is determinant of A minus lambda I, determinant equal 0. Now how we get? First you write the given matrix as it is, 8, minus 8 and minus 2, 4, minus 3, minus 2, 3, minus 4, 1. This determinant equal 0. Now what are the diagonal elements? 8, minus 3, 1. So from this subtract lambda. Subtract lambda. So we got a determinant with lambda. Now take the determinant of this. But you see different methods are there. Directly you can find the determinant of this matrix, or we can follow another formula also. I will explain that formula. Another method is there. Two methods are there. I will explain one of them. Now here lambda, lambda, lambda. So 3 lambdas, therefore it will get lambda power 3. Next, lambda square. It is an equation, polynomial. We will get polynomial in lambda. And next, what is the next? Lambda. And next, determinant A equal 0. When we find the determinant of this matrix, we will get lambda cube and lambda square, lambda and constant. Here constant is determinant. Okay, here you take alternative signs. Here plus and here minus and here plus. And this coefficient is always 1, and here we take coefficient S1 and here coefficient S2. Okay. Now what is S1? What is S1? S1 is equal to trace of A. Trace of A. Trace of A means sum of the diagonal elements. What are the diagonal elements here? 8 minus 3, 1. So 8 minus 3 plus 1. Sum of the diagonal elements of A. So 8 minus 3, this one what happened here? 6. 8 minus 3, 5. 5 plus 1, 6. S1 is 6. So here you write S1 in S1 place 6. Next, what is S2? S2 is defined as, now here what are the matrix? What is the matrix here? I will take the original matrix. In original matrix, the diagonal elements you take. In diagonal elements, the first element minor you take. First element minor means this row you delete, and this column you delete. Then the determinant of the remaining elements. It is a 2 by 2. So write the first one plus another element plus 3 determinants. So here what is this one? Minus 3, minus 2 and minus 4 and 1. Next, this element minor. What happened? This remove and this remove. What are the remaining elements? 8 minus 2, this one, and 3, 1. 3, 1. Come to this element, because these all are on the diagonal elements. Now this minor means you remove this column and remove this row. Now what happened? Remove this and remaining elements determinant 8 minus 8 and 4 minus 3. Now when you find the determinant by using calculator or directly also you can find AD minus BC, AD minus BC, AD minus BC. So finally we will get this as 11. You will get the value 11. So 11 you substitute here, S2 place. So here write 11. Minus A determinant. A determinant, use calculator and we can find A determinant as this. A determinant is also 6 here. So remove this determinant and write 6. Now this is the characteristic equation of the given matrix. Now it is a third order, third degree equation in lambda. Now find the lambda values by using calculator, or you may use any method, synthetic division or any method you can use and find the lambda values. So with the help of calculator directly we will get the lambda values as 3 values we will get. The lambda values are 1, 3 and 2. 1, 3, 2. So after finding eigen values, and these values are called the eigen values of the given matrix A. So this is the first part, and in first part I explained how to determine the eigen values to the given matrix. Now after finding eigen values we have to check whether our answer is correct or wrong. How? There is a one property. Sum of the eigen values, just now I said, sum of the eigen values is equal to the sum of the diagonal elements. Now what is the sum of the eigen values? 1 plus 3 plus 2. How much total? 6. Similarly, what is the sum of the diagonal elements? 8 minus 3 plus 1. 6. So if this property is correct, then our answer is correct answer. Okay. So like this we can determine eigenvalues to any given square matrix. So this is the process. Next, eigenvectors. So this is the second part, eigenvectors. Finding eigenvectors to the given matrix. Now what is the matrix? Here matrix is A equal, elements write down 8, minus 8 and minus 2, 4, minus 3, minus 2, 3, minus 4, 1. This is the given matrix. What are the eigenvalues? Just now we 1, 3, 2. 1, 3, 2. So first I will find eigenvectors to lambda 1. So that means for lambda equal 1, what is the eigenvector? Let x is equal to x1, x2, x3 be the eigenvector of A corresponding to lambda is equal to 1. If this is eigenvector, then it should satisfy one condition. What is that condition? A minus lambda I into x equal 0. A minus lambda I multiply x equal 0. Then only we can say that x is the eigenvector corresponding to lambda to the given matrix A. Now substitute all values here. What happened? Now A matrix A minus lambda, lambda is 1. Here unit matrix. So what is the A? And this x is x1, x2, x3 equal 0, 0, 0. Now here given matrix 8, minus 8, minus 2, 4, minus 3 and minus 2, 3, minus 4, 1. Now here minus lambda. What is the lambda? 1. Subtract 1 from diagonal elements. Now what happened? This is 7, minus 8, minus 2, 4, minus 3, minus 1, minus 4, minus 2, 3, minus 4, 1 minus 1, 0. Into x1, x2, x3 equal 0, 0, 0. Okay. Now take any two rows. 7 minus 8 minus 2 multiply x1, x2. What happened? 7x1 minus 8x2 minus 2 x3 equals 0. And I will take second row. 4x1 minus 4x2 minus 2x3 equals 0. Solving these two equations. Any two rows. From these three rows, take any two rows and solve it. And what is the solution for these two? x1 by determinant and equal minus x2 by determinant equal x3 by determinant. Okay. Now what happened x1 here? x1 means just remove that column, x1 column, and write the determinant of the remaining minus 8, next minus 2, and minus 4, and minus 2. It's a determinant. Similarly, second x2 delete. The second column you delete and write the determinant of the remaining terms, that is 7 and minus 2 and 4 and minus 2. Similarly, x3, this remove this column and determinant write down 7 minus 8 and 4 minus 4. Now we will get finally x1 by determinant of this. What happened? Minus 8 minus 2 minus 16, that is 16 minus 8 equal minus x2 by what is the determinant? 7 minus 14 and minus plus 8 equal x3 by what is the determinant? 7 minus 4 minus 28 and minus plus 32. Finally, we will get x1 by what is the matrix? First matrix. This is x1 16 minus 8. This is 8 and minus x2 by what is this? This is minus 6 minus 14 plus 8 equal x3 by what is the answer? Minus 28 plus 32. This is 4. Now delete this minus cancel. Here x1 by this is 4 8 6 2. So therefore divided by this is divided by 2, then we will get 4, here 3, here 2. So write 4 equal x2 by 3 and this is x3 by 2. Now write the x equal, this is x1, x2, x3. Now here x1 value 4, x2 value 3, x3 value 2. Now this is the required eigenvector to the given matrix A corresponding to lambda is equal to 1. So similarly, we can determine the eigenvectors to the remaining eigenvalues 3 and 2. Okay. So next part we will discuss in the next lecture. Thank you.